Alright guys, so today we have AtCoder contest, which is like beginner contest, but not really. Yeah, I'm a bit late, but it's fine. I also don't have anything set up, but it's still fine. We're here to mostly solve interesting problems, but and not all that competitive today, so it's fine. So we're given a string S of length 12. How many occurrences of zone case sensitive does it contain as continuous substrings? Length 12 of English letters. Well, okay. I guess I have to let me find it. Should be something like yeah, right. YouTube, AtCoder, ABC. Well, it's not ABC technically, it's still Zone 2021. Like a CPP, I suppose. Let's also copy it to the rest files just so that we don't have to type it again. Blue, typically type it like this for contests, right? Just in case, no. For problem A, we just, I believe the string is not all that long, so we can just say like string s, read the string, we can even write a more general version where the length of string is not fixed. Try something like this. So we'll just count occurrences, and we have to take substring from I, starting from index I of length 4, and we'll check if it's equal to zone. And in this case, I want to increment count, and we want to print count in the end. We have several test cases. The third one is, I believe, supposed to show us that the answer is case sensitive. Oh, yeah, it's horribly slow, but it's fine. Great, one occurrence here to less than or equal to most probably is the reason. Okay, 1, 3, 0. Okay, we'll submit later. So we can just go down with the problems. I mean, there should be a script for this stuff. Okay, apparently I will have a lot of video editing to do because this part is not particularly interesting. Or maybe we'll leave it, It's probably a sign of friendship. we are standing under a very high tower of height 1000 meters currently, or the rest won't be high. At a position whose distance from the tower is d, there's an undefined, wait, it's actually something different. UFO is like unknown flying object, right? Unknown, undefined. Undefined behavior is C++, not flying objects. Whatever. So it's from distance d apart at height h. Oh, there is a sample. Okay, so there is a tower and UFO. Okay. There are n obstacles between the tower and the UFO. The ice obstacle stands at the position di meters from the tower towards the UFO and has a height of hi. You want to climb up the tower so that no obstacle crosses the line between you and UFO. Okay, so we just like project the highest point of each obstacle to the tower and take max of them in projection. I mean, there's Fall's theorem that says that this. Let me draw something. Have like x obstacle is hi, I believe, and this distance is di. This is x, the height of the projection. Then actually, what is the height of the UFO? D and h. Okay. So this is D and this is H. H to HI. Now, what we should do is the following. Like, we take these two triangles, they are similar. So we want to write down the similarity between them. Similarity states that H minus HI over HI minus X. This like vertical sides of the triangles is the same as the ratio of horizontal sides, which is like this. From here, we can easily deduce x. X will be, like, we obviously divide by this and multiply by this. Yeah, cross multiply h minus hi over d minus di times di, I believe. This is equal to hi minus x. So I believe it's something like this. Let me see if I'm right. So we have n obstacles, some distance d, some h. Are they? What if there is no such? Oh, okay. So heights of all obstacles are at most. Height of the tower, so there are no problems. I don't really know. Let's say answer. Well, how many digits at most? 10 minus 3 will print 10 digits. I'm not sure what is the order of these two guys, but either one should work fine as long as they're before A, I believe. So A is our answer. Oh, that's amazing. That work. This is a good one. So I have objects. Because we're taking the max of them, we want to write it like this. And then our function is hi minus h minus hi defined. Somewhere around there, we should have one on this. Yeah, whatever, we can have everything in one level, even n. Although this is probably the stupidest, but yeah. D minus di, I work from that times di. Just close it on so that we can see something on the screen. Not many obstacles in our first test, but it's fine. Three test cases as usual. I should have time this. Looks legit, although we do have a little bit fewer decimal points. Yeah, looks fine. Just works. No math never lets you down unless it's precision issues, but it's not the case here. Problem C, math team. Oh, that's actually reverse order, so we should solve problem D. Yeah, I remember that message about problem D being less valuable than problem C. Not sure why they didn't change it, but whatever. So we're given a ciphertext S. It can be decrypted by the following procedure. Let T be an empty string for each I from 1 to length of S. In this order, we do the following. If the ith character of R is if the ith character of S is R, reverse T. If the ith character of S is not R, add that character to the end of T. I believe we can just maintain T as a DQ, right? Do whatever we want. Okay. And we also will have a flag boolean reversed starts with false. I'm not sure if we can just reverse it like this, but also lateral in the QT, we will not print a lateral and actually so that's our printing, and then we have string s that we read it. Every character in S, if character is the reverse one, else actually if the string is reversed, then we want to push front, I believe, that character. We want to push back. Not to R, but to T. That's not R. Oh, we do delete consecutive characters? Okay. I didn't read that same part completely. Yeah, no, it's fine. It's exactly what we want to apply. We can do every end. It just means that we can't blindly print whatever we want. Yeah, only two input sample inputs for us. As long as there are two consecutive characters, remove those two characters. Project file stream is not dependent. Yeah, of course it is not dependent. We just like push everything into a stack. For every character in T, and I should probably change it here. It's not confuse readers. If stack is not empty and stack top equals to C, I suppose we just pop from the stack, else we push to the stack. I'm not sure if we can just iterate over a stack, but let's hope so, because stack is just adapter for deck, right? So it should be possible to iterate over a stack, although it does not. Hello? Because it's I just redefined the variable. I should not have done it. I completely agree with the compiler. Can't have two variables with the same name as one context. Yeah, unfortunately, stack is not possible. Well, because stack is an adapter, why don't you do just this? I hope for deck it was still defined. Yeah. One and then an empty string. Beautiful. So this part effectively does all the reversals, or all the reverse operations. And then this place removes duplicates. So it's just like combination of two well-known interview problems, I believe. Yeah, let's get back to problem C. We want to choose three people from n candidates to form a team. Each candidate has 5 parameters: power, speed, technique, knowledge, and inventiveness. The power speed, okay, AI, BI, CI, DI, DI defines the team's power as a maximum of members' powers. Okay, okay. Strengths is the minimum of maximums. Minimum of maximums is a well-known problem, but I'm not sure if I solved it for 5 arrays, actually. In 3 rows. Like we clearly can't iterate over all possible options. So I suppose what we are expected to do, although it looks a bit risky, is to iterate over all pairs and then somehow use binary search to get the third optimal member. But oh my, I don't remember how it's done. Actually, how is it done? I believe we had a similar problem on binarysearch.com, which makes sense because it's a sponsored event. Let's get to problem straight away. Do not spoil anything in the chat. I'm not sure. Minimum is a very bad query. No. But I do remember that problem. It was like, oh wait, was it? It was like with 3 parameters. So maybe we should just think about this one. Okay. The first thing we can always do is read input reads. It's let's go at speed. I hope, okay, yeah, they are given in the reasonable order. So the idea is if we have them sorted somehow, maybe we do want to. Okay, idea number one, binary search shows the answer. Oh, that's can work, right? It's not no easy check function. I don't see it, but potentially I'm just blind, right? There is a function. So say we want each of the strands for each of the 5 params. We want at least one of the members to have 2 of them satisfied, right? So then each member becomes a bit mask of what is satisfied and what is not satisfied. Then we take bitwise OR of these masks, and we hope that there are 3 masks that satisfy, or that give bitwise OR a full mask. Now that I think about it, it's actually reasonable. So we're going to do the following thing. Well, for binary search, I suppose it's 1. High value will be 1 plus 1. Because you gotta have like low is always possible, high is never possible. So yeah, now for sure that at the end you want to print low because it's always possible. You gotta be careful here. Also, I believe there will be no other close, but why risk? Oh, Python habits. Okay. So if possible, if it's possible to get the value of middle, low is always possible, remember. Otherwise, if not possible, then high is never possible. It's the same thing. And then here we want define a function that takes into middle possible, returns the Boolean value, and it will scan an array linearly. Like, what does it mean that it's possible to have a strands of middle? It means that it is possible to assemble a team of 3 people so that their minimum speed, technique, etc. Is at least middle. So it means that all their parameters are at least middle, and all their parameters of the team are maximum of the members. So it means that for every member, we are just interested if if it has a value of greater than middle or equal to middle or smaller than middle. Okay, so I will compress masks into integers and put them in a set. So masks. Nothing particular interesting happens if array AJ is F with null mask. We set J's bit. As simple as it gets. Masks insert, I believe, is the. Oh. Okay, so now we have all masks. What we want to check that there are three masks such that their binary bitwise OR is a full mask. Right? There are not that many masks. Keep in mind, there are at most 2 to 5ths, so we can just look over all triples of masks, actually, right? But we are not going to do that. We are going to look over 2 masks. No, actually, yeah. We can just look over triples of masks. There are more efficient techniques, but I don't really care. If first or second or third. And we don't care about overlaps and people, it just means that we have some extra cool numbers. Like it doesn't make us any good to take twice the same person because then bitwise 4 will be just this. Right? So if the bitwise 4 is 31, which is of course 1 to the 5th on this one. And I believe we should write +1 on that side. Let me just more generic, then I can return true. That will work fast enough because how many masks there are? Do you know? Do you know? At most 32. So 32 times 32 times 32. It's 2 to the 15th, and we have a binary search, so it's fine. It's like linear scan and then something. I believe the expected solution was different because n is up to 3000. And in my solution, we can handle n of up to 100,000, I'm pretty sure. The bottleneck for me is 5, but probably for them it was n. This was their idea. So I believe we mis-solved this problem, but if it works, it works. There's not much to be unhappy about, except for that we have to write a bit more code than one would like. K equals 5. Oh, I didn't copy the test cases. That's why we need some sort of automated script. First of 4, so team and 10. And we can actually split things up a bit, but do I really want to do it? Right, because first we got to compile. 4, 13, and then 10. Okay. So far, so good. Let's jump into problem E, sneaking. On a two-dimensional plane, you are now at coordinates 1, 1, and want to get to RC, the coordinates of the UFO. Thematic contest, I must say. So when you're at RC, you can make the following 4 kinds of moves. Move from RC to, can we please? So there's 1, 1, roll, 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 call. Doesn't look like it. Roll, call. So we can move, or we can move actually. Right, left, and up, but we cannot move out of the grid. Makes sense. At some cost, okay. And when we move up, we move at a different cost. Makes sense. Choose an integer I and move from RC to R minus I at the cost of 1 plus I. So we can move down. In a limited number of moves for a weird price. Okay, let's see. What are our problems? There are not that many vertices in the graph. Our most significant problem is that there are too many edges. You know, when there are 4 edges, you just have your Dijkstra, right? But here for each cell, it has like 500 edges outgoing. And this is clearly not something you want to see, and especially for Dijkstra. And I also don't see a clear way of using dynamic programming here, so it got to be Dijkstra. Okay. So. In such problems, you typically want to make some observations about a problem that will allow you to ignore these multiple edges. But here is the problem. Like, you can go down I cells at the cost of 1 plus I. It's not the same as repeatedly going down by 1, 1, 1. This is somewhat problematic. Also, I really don't like how they provide input. I mean, the cost is here, then here, then here. What we are thinking about? I guess it makes sense when you want to compress these two into one. But okay, so we have to compress edges. How? Like ideally, there is a cost of I for the last operation, and we can just insert a bunch of edges of cost 1. But it's not I, but instead I plus 1, and there is no easy trick here. It's like we pay 1 for every operation that we make, and then we pay 1 for every unit of nets. Can we separate these two terms somehow? So when does it make sense to Oh, okay, it often makes sense to move down. And the process array is strange, or not an array, but a matrix, I should say. Okay, as we already know, there's one thing you never can get wrong, and this is read input. Right? So, got to do it at some point. Same thing. Or actually, matrix B is one shorter. Matrix A is one similar. And it should be. Then it could be. Because it does not have to be. So G plus 1 got to be at most C. Here R plus 1 should be at most I. Here. The edge length is not big. Does it matter? Does it matter? No, I suppose it is just to avoid overflows because what is the longest path? I assume we can just always move up and right. If we do it, the length of the path is 1000 and each edge length is 1000 as well. So nothing tricky here. At the length of the path, shortest path is at most 1 million, which is of course nowhere near overflowing. So we are fine with this one. These constraints are like not because the problem setter wants us to use them, but because they don't want us to have problems with overflow. What we really should do is separate 1 and I. I don't see a clear way of doing this. I really don't. It's a bit complicated. What would you do here? When we move down, we pay that price. That's why here is now. So you want to pay 1 and then 1 per lens. One per lens. Oh wait, why? Yeah, okay, of course. Yeah, that's just stupid, right? Right, we just duplicate the state. So for each vertex, we say like, if we came here when moving downwards, or we came any other way, because for this case, the cost of going downwards is 1, and for this one, it's 2. And just nothing smart here. Okay, excuse my long thinking process. Vertex duplication is always the way. You just have to figure out what is the actual criterion that you want to separate on based on. So we have two-dimensional array of distances. Or well, actually, I don't remember what was the right way to write it, so I'll just do really ugly three-dimensional distance matrix. Yeah, I understand that you don't like it. I neither do I, but it is just how it goes. We want to print. Let's think course of D0 on this one, this one. I believe that for this problem, it is better not to generate graph explicitly, but so perform all the operations as we go. I'll have this drawn here just to remind us of what is our idea. The RTQ is usually the way you want to write your Dijkstra and not sets in greater. Of course, what am I doing? I didn't even initialize it properly. Can you do it like this? Can you? Well, let's just say that it's 2 million because I'm really not sure if it's valid to initialize with infinity because integer overflows and stuff. I don't want to replace. We did move down. We started from 0 and 0. Oh wait, that's problematic. We'll need our own struct, which seems like bool done, whether we moved down or we didn't, row and column, and then distance, and then I want to return this. In which, we can't do it like this. Boolean flag. So based on distance, and then we basically don't care. Why don't we just return distance then? Do we want to min heap or max heap? I always forget. I mean, for Dijkstra, we of course want min heap, but I believe that this is largest by default. So what if we just change this to this? Or does it have to be like that? Okay, I believe it has, the operator has to be like that, and also that. Most probably, you can just make this. While it's not empty, to the top and pop it. Wait, can I just write it like this? I always forget. No, because you have to consider everything separate. Okay. So cell has a row and a column. Actually, okay. Just not to type it like multiple times. If I plus 1 is smaller than number of rows, then we can move to the right. Oh wait, it rolls up. It's actually moving upwards, right? So if distance at so yeah, distance equals. Or we can do it like that. Whatever, we will just have it like this. Have to place 4 zeros and also to make sure that D000 is okay. So if di plus 1 j first index has to be. No, you can't use d here because it's cd. Solve distance, right? Makes sense. At least a little. No, if we don't move down, then the resulting index is always false. Didn't move down, okay. Equals what? If it is smaller than cell distance plus b, ij, I believe, is the cost. And first thing that we want to do is assign, actually, yes. Second thing that we want to do is, actually here I want to add one more check if it is equal to fij, dfij. Because if it's not, then it means that it's a duplicate vertex, we should not consider it. Here we want to place flag is 0 and row, then column, and then cost. I hope it doesn't. Okay, I believe it requires a constructor in such cases. You also don't need these underscores, but whatever. Because there is no real thing that you can show you from. Should not make any difference, but why not? No, that would be bad. Or if C is at least 1, if distance of 0, why C if it should be I? No, it should be J. J minus 1 is greater than cell distance plus A. Let's be careful. Ij minus 1, I believe, is the term here. B0, Ij minus 1. Yeah, there's nothing smart here. Retype this and then what? 0, I, j minus 1, distance 0. Now we can copy paste that part because it will be almost analogous, except for here you want to check like this. And here, when you're moving up right to the right, or whatever direction this is, we'll use a ij for some reason. For input compression reasons, currently now if this f And we can move down at the cost of 1, right? And we will end in state of 1 because we moved down. Moving down is I minus 1. So if f ends greater than 1, greater than 1, greater than 1, greater than 0, and I, greater than cd plus 1, plus here, 1 minus 1, which is, let's make it uniform. And here, no, I actually should add it here. Yes or no? No, it doesn't matter. If I then cost of moving here is 2, fortunately. I don't even know, just too much code can fail in any place it likes. I really don't know. I mean, the idea looks reasonable that vertex duplication trick is always the path to follow. I believe the extra works with all non-negative edge lengths, including 0, because why not? Yeah, I really think it works. Expected answers are 9, 489, and so far so good. Gives us some hope of not being totally wrong, but sounds like -1 or -2 probably. I mean, 2 extra submissions. Let's read problem F because it should be the most interesting one. I believe we do have enough time for that. So much. It's 53 minutes in, and we have 47 more. Not ideal scenario. I already know that we like out of top 100 probably, most probably, but let's keep going. Yeah, I was thinking for way too long, both here and here, but no, that happens when you don't write const regularly. You come back after a break and you just not in the form. Like you can solve problems, but it takes you more time. Potentially, you make more bugs. But yeah, if you want to get back, then you have to do it at some point. As your startup's new product, you are planning to build warp gates that allow travel between all planets. Not bad, not bad. There are n planets on plans from M. So another graph problem. Well, grid problems, graph problems, sometimes they are different, sometimes they are not. So there is an integer where there is an integer n small such that capital N equals 2 to the power of n. Okay. To allow fast travel between all these planets, you want to make n-1 warp gates, each of which allows instant travel between 2 planets. However, for some pairs of planets that are incompatible with each other, you cannot make a warp gate between them. More specifically, such pairs of planets incompatible are presented by a sequence if any of the integer, if and only if there is an integer I such that x or b equals ai, you cannot make a warp gate between planet I and planet B. Want to determine whether it's possible to make a network of warp gates that allow traveling between any two planets. If it's possible, find such a way. What is XOR? Yeah, I believe this is exactly the question that people who got to that problem in contest ask. But whatever, n is not 18. 18. Last time I saw the number 18, it expected 3 to the power of n complexity. And everybody was disappointed about it because it's not what you typically see. I don't believe that they listen to us, so it may be the same trick again, like low power also masks and shrinks power time. But maybe it's not. Like my original idea was, of course, to my original idea was that for n equals 1, for n equals 0, it's especially easy to construct such a thing. And you can just go. This was the original idea. That you duplicate your stuff to the second part of the hypercube, and then you just add one more edge. There is a problem like all edges in some direction, maybe bent, and then you have nothing to do. Yeah, actually, 0, 0, 1, 0, 0. Let's say this was 0, 1, and here we have 1, 0, 1, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. So here we have 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1. So typically you would build like one edge over such thing. But an interesting property that I can clearly see here is that all these edges, their endpoints have the same XOR value. If it's banned, then it's completely banned. Right? You got to connect components in a different way. And then n is at most n minus 1. Wait, what? What? There are n principal directions, and they ban at most. No, n is most capital N minus 1. Okay. Oof. This actually sounds hard. I believe that we should submit all our problems just in case. And then I'll leave this hypercube madness for later. Problem A, GCC, do I want GCC or conc? Compiler or wait? Oh, it's GCC specific. Oh my goodness. Okay, good thing that compile error is not -1. You should be really careful. Okay, problem A got accepted. Problem B is executed. Problem B got accepted, which is good because it was floating point. Arithmetic, which is never good. Problem D, let's see. Problem E. Problem C got accepted. Well, we still have problem E, which is almost surely wrong. Problem D got accepted. Let's wait for problem E. Okay, not that much to spare. I mean, it's only 10 times faster. Probably if you generated the graph explicitly, then it would be quite problematic. So now, well, that remains is problem F, I believe. We are terribly bad in the standings. Rank 300 is my prediction. Approximately. We should not think about this. We should think about the problem. Okay. You probably know what I'm about to say. There's one thing that is never wrong. This, it is to capital M. Do I want capital M? I'll have K as my block. I believe you can never get wrong if you add a bit. Like even the flock is imprecise. Wait, did I? Oh no. Of course, this is completely wrong. You should never do it like this. You should do it like this. What's up? Promoting bad practices. You know, what else would you expect from a competitive programmer? Yeah. I find it fascinating, this fact about directions. Moreover, like if, for example, let's say you don't bank SOR of 1 or 2 or any other power of 2, you bank SOR of 3, you delete these edges. And you always delete like set of edges, perfect matching you delete, right? And wait a second, you delete perfect matching. I believe that if there are at least 2 perfect matchings in a graph, no, not necessarily, not necessarily. But like they have special structure. Well, wait, here is XOR of, should take this one. Oh, that's 100, so 100, right. These are the things that you delete. I believe that if you have at least 2, then it's possible. But it works very handily. It should be the case. If you have at least 2 with remaining. Have at least 2 such special matchings, and it should be possible to combine them. Or should. No, wait, I'm stupid. Like if we have red and green remaining in this picture, then we can't. Yeah, obviously. But if we do have a matching that is not deleted, Then we can build all corresponding edges. And n is at most 18. One thing that comes to mind is the joint set union, so that we always know if we should build an edge or it will just keep the components connected. And it should be fast enough, even though we have like 200,000 vertices in the same number of edges, but we can't iterate over all edges. Oh, that's hard. That's hard. Or maybe we need at least a small n of cardinal directions. So k in our case. If we can have coincidence and we just, for example, for that case, we would need at least 3. Is it correct? No, it's not correct. No. It's still, I'm still wrong. We can remove this, and we can remove this, and then this, and this. They always have a XOR of 100, which is 4, of course. So we have 3 capital directions, and still we don't have anything. No, it's not clear how to proceed with this problem. Like, I believe that the observations we made are important, but not enough. We should take a break here and think about it. I will pause recording. Right. So I will explain my approach on as. Wait. So you see, there are multiple ways, I believe, to separate our graph to make it not connected. I believe, or I really hope that it's so, that the only ways to separate them are to like cut through the hypercube. And what it means, if you take a closer look, like if there is a value, like why these two guys are separated at the moment, although we have many edges? Because all possible edges, they have second bit source of endpoints of every edge. They have second bit off, and this disconnects the graph. If everything having second bit turned on is bent, and graph gets disconnected. So what I propose is to open our disjoint set union somewhere from code forces. Well, that's kind of works. Clear difference between contest code and non-contest code, but so DSU is used only to keep track of what is connected and what is not. U of n. Because now we are going to do the following. So we will need a mask. And initially it's turned off. 0. Oh, AI is sorted. Nice. That is really nice of them. So yeah, I don't really need this part. So the idea is for either bit, if there's an integer that is not banned and has its bits turned on, then we are golden. Right? If there are no integers that have some bit turned on, and we have a good cut through. It's not nice. Because it means that we can't connect anything. So if I is equal to wait, IDs are what? Numbered 1 through n. Why would you do that and not 0 through n? Why? Just why? I don't know how to adapt it to the setting when we have indices shifted by 1. I really don't. Like, it's important. Because now we can, well, 2 to the power of n is basically 0, right? Because we are never getting, we don't have such sort. Like it can always be connected with everyone, no? Not capital N can always be connected with everyone. What? Excuse me? But they output in the sample output, you output indices 0 based. In the problem statement, it's 1 based. Don't you see a contradiction here? Literally wasted me several minutes. Bits times, yeah, I'm fine. I mean, if mask and there's no such bit in mask, so we have to add it, right? And if I has this bit turned on, if it's banned, then we skip it. If it's not banned, like if it's banned, then we skip it. Also, I should put the index for array A and smaller than M, I believe, should be here. If it's turned on and it's turned off in mask, then I need to add it to mask. So mask gets, but more importantly for, and don't be very scared of nested loops because this loop gets executed only once per bit. Although I probably should name it tarball codes, don't use it immediately. What should I do? What should I do? vector pair and edges. Find I not equals this, you'll find. So if they are in the different sets, and it makes sense to add, I probably missed a couple of parentheses here and there. And it makes sense to first union. Oh, yeah, that's the case. And second, I just replace back this edge, right? Because that's what we wanted. This. Probably. Mask is a full mask. And for every edge, we want to print its endpoints. Extra line, not sure what that does. Otherwise, we want to print a -1 apparently. I'm not sure if it's right, but I believe that all cards that can occur are of that form. Otherwise, this problem sounds impossible. But maybe I'm just stupid. No, I don't see a transparent solution. So 0, 1, 1, 3, 0, 2. Well, the difference of only 2, 3 or 1, 3. But neither of these source is bent. We have 3 bent, we don't have 1 bent, and we don't have 2 bent. Here, 0, 1, 2, 3 is not bent. We don't have bent source at all, so we can 0, 1, 2, 3, 4, 5, 6, 7. Yeah, it just makes perfect sense. It's exactly what I drawn in the case I drew. Excuse me. In the case when we don't have bent, innocent bent. Let's just try it because we don't have better options. Hope for the best. Maybe it's wrong, and I just wasted like several minutes of your time. Oh, it's already wrong this one. Okay, not great. But how wrong is it? Significantly wrong. It sounds like they tell me that different cuts may occur. Yeah, like actually even our simplest case appears to not to work with that logic, right? Because the simplest case is a square, and we can bend red and blue, and this green will be like 1, 1, and what, and nothing. Right? So if someone was to bend red and blue, this edges correspond to XOR of 3, which has all bits turned on. It doesn't help the matter. What we can do instead is like take only one bit from every integer. Well, let's make sure that n is 4. We have two band numbers. These are 1 and 2. No, I didn't mean to. What that is S4, F4 inputs. So here I believe we produce incorrect solution. Yeah, we have two addresses which clearly cannot connect. Graph. It's always good to, if you think that your solution is buggy in any way, it's always good to find a specific test case and it doesn't work, then to just change something and hope it works now. Yeah, well, at least we fixed one test case. We can already be, if we do it 18 more times, there are high chances that it will work. Yeah, probably. What we actually want is enough of these guys to be linearly independent. If we have k linearly independent guys and it works, otherwise it doesn't. No, it's still wrong answer, but it's later, I believe. So there were 18 failed test cases, now there are 6. Think it more. Yeah, the problem may be that we don't take the correct one from every number. We should use it more. We should use some number like in a different way, right? The order in which we take these set bits from numbers is pretty arbitrary. We simply can't take because we can't take something. It does not necessarily work. But in our case, like let's see, what can be an error? Because we only take one bit from each thing, if we connect, they all have different bit sets on, I believe, and then we cross every cut, but this is a different cut, right? And we have enough time to run this thing several times. And then actually count the size of this joint union. Size. Our union is subtract one from sense. So size equals one, then we can print everything. And judging by time limits, we can make it from the. I don't really know what we are doing, but this is more better condition than the previous one. No, but it will just use the same bits over and over again. Right? Should somehow address this issue. Since once again, I don't really know what I'm doing. This is not supposed to work. Maybe it works. Use in not used at L. Used at L and insert and this Python. No. And I said that it's always good to find the extra example, but I didn't this time and I don't plan so. Or do I? The idea is when we don't want to take first from every number. No, I really don't want it, so but this is at least as good as our previous attempt because we changed the criterion based on which we output answer to the correct one, 100% correct one. So the answer now it becomes only whether we can construct the tree if it's constructible. And it does, but it's like, I believe it's wrong, like completely wrong. This is not the expected solution. It is just some magic. That it works, you should not use this solution. I really hope to see a correct solution. The idea here was like we really want to find some subsets of like k numbers that are as a binary vector, they should be linearly independent. I believe the solution goes along these lines. And I somehow solved this problem with just stupid tries. Tried 10 times. From every number, I tried 10 bits, and with a high enough chance, it finds what it should have found. And we have that high enough chance because we have enough tries. Because our disjoint set union is fast. Whatever. This is clearly not what was expected, but I'm happy that we solved this problem. We got accepted. We did not solve this problem, but I believe we will find the solution soon. Yeah, it was a bit nervous. I believe that's horrible understanding because like I missed correct solutions to I missed correct solution to one problem. I missed expected solution to other problem. No, not bad, because not many people could solve this problem, but at the same time, some people solve it in like 7 minutes. Crazy. I'm not good at this bit stuff. I can just try a naive approximation. It will be actually interesting to, I mean, they generate test at random, but they know something about the problem. They know something about the structure of the correct solution, so that I would expect they can devise adversarial test cases for like naive trials. Because I believe that what I implemented is very persistent naive trials, and the persistency got us accepted. So it would be interesting to know what is exactly the probability of such a solution getting accepted. It's probably high, but not much, not very. I have to ban specific sets of numbers to get it not work. Yeah, the idea is to connect along some bits in some numbers. This doesn't seem to work exactly as stated. It would work if these numbers had only this bit turned on, because then it's like cardinal directions, like horizontal, vertical, depths, whatever. But it doesn't work this way in the general case. Well, we'll find out soon. Wait, I'm actually surprised. How does it happen so that first 20 places are Japanese? I mean, it's a Japanese site, but then there should be some people. Okay, shall have some. We have first then people who didn't solve the problem. Impressive. But we also didn't solve the problem. We were just resistant and got accepted. Okay, I believe this is the time to end the video because there is not much I can tell you about this problem. Like all the ideas we tried were reasonable and incorrect, but somehow we got accepted. So that's the moral of the story. And this happens in competitive programming. It doesn't in competitive math, if you ask me. Like recently, a team selection test to the International Mass Olympiad finished in Ukraine, completed. Yeah, so I was grading the papers there, and like you can't pass tests in a math problem if the solution is wrong. Right? The jury will find all your errors, unfortunately, and you will not get points for your own solution. But in programming, it sometimes happens. Not much we can do about it. Yeah, so see you in the union and binarysearch.com. Bye-bye, guys.